I'm not sure if it's recording or not. Let me check. Perfect, perfect, perfect. So I don't know why the time is not coming up correctly, but let me just start the clock for an hour, and let's grind LeetCode. Okay, so I have just solved 19 questions. I'm following this roadmap, so let's start. Let me put it here. Receive. Okay, replace elements with greatest element on the right side. So you given an array, replace every element in that array with the greatest element among the element to its right place, and replace the last element with one. After doing so, return the array. So this is here. So basically this will be replaced by here, and this then 5 will be but how 5 is gonna come in the first, because right side is this thing, so it got replaced here, then it comes 4. uh, then 2 comes here, and okay, so this, okay, so this is here 4, this is here 5. I mean, this is, okay, so to the right whatever is the greatest, so after 2 whatever greatest is 5, so I'll replace here with 5. After 4 the greatest element is 5, so I'll replace it here with 5. Then here 5 the greatest element is 3, then it comes 3. Then here greatest element is 2. Okay, now I got it. Okay, this was quite tough. And if there is no, then -1. So how will I do it? How will I do it? So my logic is going to be that I'll be iterating over the string. Uh, Iterating over the string. How can I do it? Like it's gonna be one iteration is not possible. That's what I can think, because I have to iterate anyhow. Topic, let's say topic is on array, but using array, how can I do it? um, so sorting and reversing is not gonna work, because it's, I mean, one of the solution is that I can have two arrays. uh, 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 I can do it in this way, that I can find the max of the array at that in iteration. So let me do it in this way. So uh, for self in array, for self in array, oh no, self is not something. So for I in array, if so basically I have to use the max function. Gemini, is there any max function to find the maximum in array, maximum number in array? In Python it's maxnums. Okay. And I can define here new is equals to this, and then new at I is equals to max of ARR from I plus 1 till end the end. If I is equals to len of ARR, then till then. If I is not equal to length of ARR, then else new else new dot append -1 and return new. Run. I guess it's not defined. Out of range, it's not defined, right? So I can write it new dot app. Let me just use this logic. It worked. My solution worked. So So this append was the same thing which I did. uh, uh, but what I was doing wrong, I was doing wrong something. uh, when running this, I was getting the error that this line is not correct. But if I just but this looks good. Replace new to depend iterable argument. in in my solution I got this error. What I did wrong? uh okay, okay. For I in range assigns the actual number from the array to I, not the positions. Okay, assigns the, okay, for in Python, for I in range here assigns the actual number to the array, not the position. If your array is oh, okay, 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 okay. Okay, so your the logic error at the end check is intended to catch the element, but it compares the value of the element to the length of the even if few indices used. Because the Python trained, okay, because this condition says true, the code eventually tries to find the max of the element on the rise of the last element. Okay, got it, got it. How to fix it? To fix immediate error, you should use the enumerator to both. Okay, for idx for idx value in enumerator is the position. Check if the position is, if this is later in the index array. Now append. Okay, I was not using the idx for I less than. But then how this works here, also we are not using any enumerator. Great question. The reason there is works while the original version crashed is all about the variable I actually represents. In Python, is a difference for I in range length. Okay, okay. So they have used range L. What they have used is the what they have used. What they have used is uh, it's range L. Okay, got it. So this I learned. This I learned. This I learned. Okay, so they are using range L. So range is going to be range is going to help us in iterating, and then I is append, and with that logic I get the I, and when the I is length, I'm gonna append all the max. Got it. Company tags, LeetCode Pro. Okay, okay, okay. Now solution. Hint, they did not have given us the hint brute force. For each element at index we need to find the maximum value among all the elements, right? So okay, that was a brute force. The most straightforward is just to scan every element to the right for each Python using index I, and so but for brute force they have used the this thing where I just avoided that by using the Python. Suffix max. By traversing right to left, you can maintain a running maximum of all elements seen so far. Right max. Let me watch this.
We're going to start at the end of the list. Place elements with the greatest element on the right side. So we're given an array, and we want to take each element in the array, for example 17, and replace it with the greatest element on the right side. So we scan through 18, 5, 4, 6, and 1. The greatest one is 18, so we can replace 17 with 18. The last element, 1, doesn't have any values that come after it, and the problem wants us to replace it with a -1. So basically what I do is just consider that there's an imaginary -1 over here that's not a part of the array, but we're just going to replace 1 with this -1. Now, if you don't know how to solve the problem, the first thing you want to do is draw a picture. This is going to make it a lot easier for you to visualize it and notice patterns. So once you've drawn the picture, choose the easiest way to solve the problem first. So we already kind of did that. So to replace 17, we're going to look at every element that comes after it. So each of the 5 elements, and we're going to take the maximum of these 5 elements. And we see that 18 is the max, so we replace 17 with 18. We can repeat this process. So for 18, we look at the last 4 elements. We see that the max is 6, so we can replace 18 with 6. To replace 5, we look at the last 3 elements. Again, the max is 6, so we replace 5 with 6. To replace 4, we only look at the last 2 elements. Again, the max is 6. To replace 6, we only have to look at the last element, which is 1, so we can replace 6 with 1. And of course, 1 is going to be replaced with -1. Once you draw it out, it's pretty easy to recognize the repeated work that we're doing. Because of the repeated work, this solution runs an O of n squared time. It's also obvious that since we're doing a lot of repeated work, that there is a better solution. So let's try to analyze it to come up with a pattern that we can use to make it more efficient. So the first thing that I notice is that the new value in position 0 is equal to the maximum of each value that comes after it. So in the array from position 1 to position 5. To get the new value in position 1, we did something very similar. We scanned through each of the last 4 elements. So we took the max of the array from position 2 to position 5. So this makes it even easier to recognize the repeated work that we're doing. We're taking the max in the array from 1 to 5, and then we're doing the max again from 2 to 5. Wouldn't it be easier for us if we took the max from 2 to 5 first, and then stored that value, and then to get the max, or to get a new value in position 0, all we have to do is take that stored value and compare it with the original value in the array in position 1. Let me draw it out to make it even easier. So the thing to notice is that these 2 equations that we wrote to get the new value in position 0, they're both equivalent. But in the original value over here, we have to get the maximum of 5 different values. Over here, in the new one we wrote, we only have to compare 2 values to get the maximum. This cuts down on all the repeated work. So the hint here is that to get the new value in position 0, we have to first get the new value in position 1. And to get the new value in position 1, we have to get the new value in position 2 first. So this problem leads us to iterate through the array in reverse order to cut down on the repeated work. So we're going to start at the end of the array and then compute the new values in reverse order. Of course, the new value in the last position is simply going to be -1, because that's like our base case. Okay, so let's go through it in reverse order. So our max value initially up until this point, before we've even gone through the array, is just -1, right? That's our base case. So we're going to replace 1 with -1. Now we want to recompute the maximum, right? And we only have to look at 2 values to do it. We only have to look at +1 and -1. So our recomputing the max up until this point is going to be +1. So we can replace 6 with +1. Now we're going to recompute the maximum again, and all we have to do is look at 6 and 1. 6 is greater, so 6 is our new maximum. We can replace 4 with 6. Now we're going to just keep repeating this, right? So our new maximum up until this point is 6, because 6 is greater than 4. We just have to look at 2 elements. So we can replace 5 with 6. Now we're going to do it again. The max up until this point, we just look at 5 and 6. 6 is greater, let's replace 18 with 6. Now let's recompute the max up until this point. 18 and 6, 18 is greater. So we can replace 17 with 18. Now we can recompute the max here, right, between 17 and 18, but there's no point to do it because there's no more elements that we have to replace. So now we've done it. All we had to do was go in reverse order, which cut down on all the repeated work. We didn't need to use any extra memory, and therefore the solution, the runtime, is just O of n. Now let's write the code. So before I write the code, I like to write a few comments to remind myself what to do. So we remember that the initial max can be set to -1, right? Because that's the last value, that's what the last value will be replaced with. And the reason this works is because it'll eliminate some edge cases for us, and we know that every value in the array is positive, so we won't have to run into any extra edge cases. The next thing we want to remember is reverse iteration. We're going to start at the end of the list and go backwards. Lastly, we know that the new max is going to be computed by taking the maximum of the old max and the previous position in the array. Keeping this in mind, it's pretty straightforward to write the solution. We're going to initialize the right max to be -1. Then we're going to iterate through the array in reverse order without creating a shallow copy of the array. We can start the last value in the array. We're going to iterate in reverse order, and we're going to stop once we get to the beginning of the array. We're going to replace the value in the current value in the array with the right max. We know we have to recompute the maximum, right? But we're overwriting the value in an array, but we need this value to compute the new max, right? Just like we wrote in the comments. So when we compute the new max, let's do it before we overwrite this value. Lastly, let's update the current right max with the new max that we just computed. And the return value that this function wants is the array itself. So we can do that, and of course, let's submit it and see that it worked perfectly. So these are the steps you can take to solve this problem.
I'll replace it at the end. But my question is like he is still working on that. Uh, why he did in the reverse order and not on this? Okay, no worries. There's never a in sequence. You are given two strings s and t. Return true if s is subsequence of t or false otherwise. The subsequence of a string is a new string that is formed from the original string by deleting some. Can be none of the characters without disturbing the relative positions of the remaining character. Is a subsequence of okay, but not AEC. Okay, this is an interesting one. भाई level up हो गया गेम में. कैसे करेंगे इसमें? Basically the question is that the question is first of all whatever the element of the given, that should be present in that same order. But how can I identify it? How can I identify it? So this is 2 pointers in dynamic programming. I have no idea, and this has no clue. First, I will ask Gemini how I should approach this problem. I have no clue that how should I doing it. Even with the brute force, I know that the given string and from which I have to compare it, that value. So if I iterate over this one, that should come in the same order in this one. But the efficient way to find that, because there may be 2 or 3 letters that may be same. But no worries. How to approach this problem? Analysis. There is a subsequence problem is a classic string manipulation challenge. To solve it, you need to check if you can find all the characters of S inside the string in the same order, even if there is other character in between. The mental model 2-pointer approach. Imagine you have 2 pointers. Finger S points at the first letter of S and the finger T points at the first letter of T. If the letter matches, move both the fingers to the right. You found one. If they don't match, move only one finger T and look for a match further down the line. If S reaches the end of the string S, it means you found everything. Step by step Python strategy. Okay. So 2 pointers may basically they have declared 2 pointers I and j. Keep going until we run out of the letters in either strings. While I is len S and j is length of t, if I is equals to tj, then I plus 1 I की value बढ़ा दिया. Always move the pointer for t to keep searching. Always move the pointer t to keep searching, because we do not want to come back to search that same thing. If I reach the length of s, right, but how to approach its company tax topics? Solution. Before attempting this problem, you should be comfortable with 2 pointers, recursion, dynamic programming using memorizations or tabulations to avoid redundant computations. I know nothing. Recursion, I know, breaking down the problems to smaller subproblems with the base case. Recursion. So to check if S is a subsequent of T, we need to find all the characters of S in the T in the same order through not necessarily contiguous. Because reversely, we compare the current characters of both the strings. If they match, we advance both the pointers. If they do not match, we only advance the pointer in T to continue searching. The base are remaining the end of the S and define a recursive functions are where I is in the index and S and J are in the index. base case, if I is equals to, then all character must match I is equals to length of s, all character match, return true. If j is equal to ran out of characters in t, if j ran out of characters in t, what does that mean?
Hey everyone, welcome back, and let's write some more LeetCode today. So today let's solve a problem, is subsequence. So subsequences come up a lot, especially in dynamic programming problems, so this is a good question to kind of get familiar with them before you solve some of those harder dynamic programming problems. Problems like longest common subsequence, which is a problem that I'm probably going to be solving pretty soon, probably in the next video. So we're basically given two strings, right, s and t, and we just want to know if s happens to be a subsequence of the string t. So first you have to understand what a subsequence is. To say that s is a subsequence of t basically means that all the characters from s, so let's say that this was our string s, all the characters of s can be found in t, right? Let's say this is our t string. All of the strings from s can be found in t in the order that they're given. So ace, right, A-C-E can be found in this string with eliminating some characters. So you take the A, you can find it in the first position. You take the C, you can find it in the third position. And you take the E, you can find that in the last position, right? We're not required to use every character. So basically what we're doing is getting rid of the B and getting rid of the D, and then you can see that this string becomes ace, right? So therefore ace is a subsequence of T. Take a look at this. If this was our string S, it would not be a subsequence. Even though the characters can be found, right? A, E, C can be found, they're not in the order that they need to be in, right? So it seems like a pretty straightforward problem, and that's because it actually is. That's why it's an easy problem. So we can actually do this with a linear time algorithm, basically by comparing the two strings. So I'm going to show you how to do that right now. So the first example returns true because S is a subsequence of T, but how can we determine that? How can we prove that's true? So it's actually easier than you might think. We're going to use two pointers. So I'm going to have one pointer I initialized at the beginning of our string S, and I'm going to have another pointer J initialized at the beginning of string T, right? And really, we're just checking all of these characters. We want to check them off. We want to say, okay, A can be found in T, B can be found in T, and C can be found in T, right? And if we have some extra characters like these, it's okay. We're allowed to skip those characters. So when we're using our pointer J, we're allowed to skip some characters, right? But we want to, with our string S, we really need to know that every one of these characters can be found here. So it's a two-pointer solution, right? We initialize our pointers. Let's compare. Are these two characters equal? Yes, exactly they are. They're both A. That's what we wanted. We needed to find an A. So now that we found that A, we can shift our I pointer to the next position. We're going to be looking for the next character B. We also have to shift our J pointer because we're not allowed to reuse this character, right? So we shift our J pointer over here. And now we're looking for B, so compare B with H. So this is H, right? That's not B, that's not what we're looking for. So since we didn't find this character, we can't shift our I pointer. But we do have to shift our J pointer because this is not the character we're looking for. We have to check the next character. Now let's compare the characters. B equals B, great. So we found the character. We know that when we find the character, we actually shift both of the pointers. So let's shift our I and let's shift our J pointer. And now the only character we need to find is C. So we look at G, it's not C. So in this case, when we don't find the character we're looking for, then we only shift our J pointer, right? So J is D what we're looking for. It's not equal to C, so we shift our J pointer again. So now J is over here. That's the character we're looking for. We found C. So we shift our I pointer once more. Once I is out of bounds, that means we found every single character we were looking for, right? And we can check every one of those characters off. That means we found our solution. So that means we can stop the algorithm and return true. So CJ, it doesn't really matter where J is or what it's doing. Once I reaches out of bounds, we are done. So we return true. So now let's look at the second example. How do we know if that S is not a subsequence of T? Basically, how do we know when we need to return false? So we're going to run the algorithm exactly as we just did. So we're going to initialize I and J just as we did. So now we want to find this A, right? The first character. So we compare it. Yes, we found it. So when we find the character, we shift both of the pointers, right? So I and J are at the next position. So now we're looking for X, but you're going to see we don't have an X in the other string. So let's look at this position. H, that's not X, right? So we shift our J. B, it's not right. We can show you the code. So as we showed, our I and J pointers are both going to be H, J. I think we'll increment J, we can get rid of some. Okay, so once this is J, we need a that will only increment J. We are equal, so S at position I is equal to T at position J. That's one condition. What are we going to do in that case? Remember, we're shifting both of the pointers, so we increment I and we increment J. If that's not the case, remember what we're doing. We didn't find the character at position I, so we don't increment I. We only increment J, right? So we increment J by 1. And this is really all that we're doing. So, and actually, when you take a look at this, we can actually simplify this. We see that J is being incremented in both of these condition statements, so we actually don't need a condition for it. So we can get rid of this, because J always is going to be incremented regardless of the comparison. Okay, so once this loop is done executing, how do we know if S was a subsequence of T or not? Well, if we reach the end of our string S, right? So basically, I is equal to the length of S, meaning that for every character in the string S, we were able to find a matching character in T. Then we're returning true, right? So this is how you can do it in Python. And if that wasn't the case, then we're returning false, right? Because that means if this was not the case, that means our loop ended, right? That means J went out of bounds of T. That means we searched the entire T, but we couldn't find a matching character for every character in our string S, right? So basically our loop terminated, it stopped executing before we could find every character. In that case, we have to return false. So this is the entire code, and it works pretty fast because this is a linear time algorithm and no extra memory required. You can see it is pretty efficient. So this is basically a little beginner lesson in how subsequences work. Next time we'll probably be handling a difficult dynamic programming problem involving subsequences. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hope.
Was tough for me. He used dynamic programming thing, but his solution was a bit different. His solution was short, and what he was saying that while I is less than len S and J is less than len T, if Si is equals to Tj, then it's I plus equal to 1, and then J plus equal to 1. 1. Return true if I is equals to len S, else false. Let me first run it and just check. Oh, it should be double equal to run. What's while and J is len T? Oh, I have not defined I and J. I comma J equals to 0 comma 0. Run. Okay, how he is doing is that we have I and we have J pointers defined at 0 0. If I is less than equal to the length of S and J is length of the length of T, and if दोनों का position same है, then we will add I and J भी हम लोग एक step आगे कर देंगे. Then now I is 2 and J is also 2. If they are same, then we do it, otherwise just सिर्फ J को करेंगे. And जब J को किया तो उस टाइम पर I उतना था. Now true, if I is equals to len s. Okay, if right, if I is equals to length of s. I understand, but what is dynamic programming? What is understood? So, let me submit this question. LeetCode question is subsequence. LeetCode question is subsequence problem run it, submit, and then I will go here in the back, Control C, Control V, submit. All right, good job. Let's move to third question. Append characters to string to make subsequence. Okay, append characters to make string subsequence. Okay, append characters to string to make subsequence. You are given two numbers s and t consisting. You are given two strings s and t consisting of only lowercase English letters. Return the minimum number of characters that needed to append to the end of s so that t becomes a subsequence of s. A subsequence is a string that can be derived from another strings by deleting some or more characters without changing the order of the remaining characters of a coaching. COACHING and coding. So basically D is not there. So string that can be derived from there. Okay, return the minimum number of characters that need to be appended at the end of s. Append the character ding at the end of s so that but इसमें तो ing common है, like the ing is already here. You are given return the minimum number of characters that needs to be appended to the end that becomes subsequence. So from other string by deleting some or none characters without changing the order. Okay, so other order needs to be same. So I think this can also be tackled using a two-pointer method approach that we discussed. We'll define a pointer here and we'll define a pointer here. If both of them are equal, so they have to move together always. If this element and this element is equal, then good. If the next element is also equal, then good. If the next element is not equal, then from there if the not, then we will increase this one to check if there is that present or not. Okay, so we go to C and then we'll compare if C is present here or not. Then we go H, then we present. So if none of them matches D, then from D till the end we will add. But if D comes then we are not going to add, then we will move to the next character in both the times, and then okay, so here I got that. So here is A, B, C, D, E, so इसमें 0 needed because both of them matches. So we have to exit. T is already subsequent over Z, and Z nothing matches. So basically, nothing matches. So if the iteration length gets away, then we basically have to add everything. So it's a 2-pointer question for sure. I can guess that 2 pointers, strings and greedy. Alright, so how I can do it, I will define by ij equal to 0 comma 0, and for for I in range of s, for I less than range how to do it for I in, so j for I in range s, because we have to iterate over everything, right? If for I in range s, भाई ये क्वेश्चन हो जाएगा ना, मज़ा आ जाएगा. For I in range s, for I in range s, how I have to so एक कंडीशन तो ये है, मुझे जो कंडीशन पता है वो तो लिख सकता है. if si is equals to j of I, no, if equals to t of j, which is both 0, how they did it, let me go back to this question. So while I is less than s and j is less than 3, so I'm going to use the same condition. While I is less than range is range of s. I'm just thinking whether j is less than range of t, and if f is equals to, if s I and ti is equals to 0, then we'll ignore it, then we will ignore it, and I will be equal to plus 1. Alright, I will be equal to plus 1. Then we will increase j plus 1, we also have to do it, or j plus 1 we have to do it, right? Every time we have to do j plus 1 for sure, else if they do not match, then we'll go j plus 1. No, we'll go if they matched. Okay, s of I si is equals to t of I. Si is equals to t of I. So a b c d e और b c f. So पहले यहाँ pointer है, then यहाँ pointer है. It did not match. then इसका pointer increase किया if this is equals to this or not. अगर equal है then दोनों का pointer increase. Okay, if s of I is not equal to s of j, then j plus 1 and I plus 1. If they match, then both plus. If they do not match, then only j plus. If they do not match, then only j plus. If they match, so if they are matching, they are getting plus. If they do not match, then they are getting both plus, right? Okay, so this is gonna be our loop condition. If they match, let's say this match, then both of them will be plus. If they do not match, only this will be getting plus. Okay, now number return how much I have to return if this got finished. If the length, if t becomes equals to, if j becomes equals to length of t, then return 0. Then return 0 if a b c d e भाई सुबह सुबह इतना दिमाग, भाई मैं इसको स्टॉप कैसे करूँगा और हाउ. सो द इशू इज हाउ टू काउंट. इटरेशन तो मेरा चल गया, बट लेट्स से if I becomes equals to length of t and t is not equal to length of t, then return j minus t. Okay, if j becomes equals to length of t, length of s, and t if I become length of s, जब दोनों मैच कर रहे हैं देन वी हैव टू यूज़ जे. जब दोनों नहीं मैच कर रहे देन आई तो हम लोग कर ही रहे हैं हर स्टेप पे, राइट? इफ़ आई बिकम लेंथ ऑफ एस एंड and j is less than length of t, then return length of t minus j, else if j becomes length of t, then return 0. I mean, anyhow, जैसे ही j का लेंथ i का लेंथ ख़त्म हो जाएगा, then I माइनस ये मैं ऐसे कर सकता हूँ. If I become length of t, then return length of t minus j, and if j is equals to length of t, इक्वल अगर नहीं हो, भाई इसमें बहुत सारे एज केसेस हैं. दिस इज गोना फेल. कितने मिस्टेक्स कर रखे हैं मैंने. रेंज एस, okay, now I'm good. I'm not able to understand. मैं try किया solution. Before attempting this problem, you should know 2 pointers. I know this was a 2 pointer subsequence. Understanding the subsequence that make a sequence of another greedy algorithm recognizing 2 pointers. To make a subsequence, we first need to figure it out. How much t is already a sequence of s. We can greedily match the character from t and s from left to right. Once we know that how many characters of t can match, the remaining characters must be append. The greedy approach works because earlier character in S never hurts. If a character ST appears multiple times, taking the first occurrence leaves more room for matching subsequent character. Use pointer I for sharing S and J for So basically use two pointers I and string S and J for string T. Iterate through S. Whenever S of I matches, move both pointer forwards, otherwise only advance I. Got it? That's what I'm trying to do. After scanning S and J represents how many characters of T are already. After scanning S and J represents how many characters of T are already matched. Return len T minus J the number of characters. That's what I'm trying to do. So what कहाँ गलती हो गई? ये मैंने गलती यहाँ पे कर दी थी, ये ऐसा. बट फॉर लेंथ ऑफ एस ओके रेंज इसमें नहीं आ रहा है, इसमें लेंथ ही आता है. वाइल में रेंज क्यों नहीं कर रहे ये लोग? ओह ओ भाई, मेरा सॉल्यूशन सही था. मैंने बस यहाँ सिंटैक्स एरर कर दिया था भाई. लेंथ ऑफ एज basically I was using range and idhar मैं ऐसे use okay. Can you help me to understand okay, so I was just solving one problem and I recognized that when using for in Python we use range, and when using while we use length of a string, like when we are dealing with string. Can you help me to understand why this is different? Can we use, is there a situation where we can use range in while and length in S when dealing with string the opposite way? It can be definitely feel a bit confusing at first. Both for while and lives are used to be repeat code. While they think they are the key difference. For is assigned to be automatic, while is designed to be manual. The for loop automatic layer. For loop is built-in grab items from a collection of one. For S, char and S. Scene is just give the actual letter. For I in range, this is the index. So where you use range, for needs a sequence to walk through range, right? बट रेंज तो हम लोग ले ही रहे ना बे. Anyhow, this is, I don't know if this is needed or not. Oh, no, एक use case के लिए नहीं हो रहा है, and then this use case matches everything. Oh, I have not submitted. Continue. I need to submit this. I need to submit this. भाई आज 3 क्वेश्चन हम लोगों ने पेल लिए. It was a medium level question. We were able to solve it. भाई मजा आ गया. We solved 21, 3 questions from there. I guess that was all. It was a successful day I solved 3 questions जिसमें last वाला मैंने खुद से किया with all the logic. I did this small mistake. And the best thing is that I solved one medium today, 20 easy. So it's good. I'm happy. Alright guys, it's time to over the stream now. If you were with me, I know there's no one at this point. But yeah, let's connect